This is for section 6.4, day 1, part 1, simplifying square roots. You're going to watch this video for tomorrow's class and the next video named section 6.4, day 1, part 2.
Alright, so we're going to talk about 6.4. This is simplifying square roots. And now that we did 6.3, we classified, we know what's rational, what's irrational. We're going to start simplifying these things. So our essential question, what are you supposed to be able to answer in grave detail when you end 6.4 is our essential question. How can you simplify expressions using square roots? So we're going to do expressions. Those aren't equations. So we're going to start back in our basic skills and our key vocabulary. You can add or subtract radical expressions the same way you combine like terms. So let's go back to combine like terms and do a quick refresher in our brain, and then we'll extend that into the radical world. So, combining like terms. If you remember correctly, we started with something like 5x plus 4x is when we started our combining like terms. And what was that true meaning between like terms? And if you remember correctly, they needed the same variable part. Same variable parts allow us to regroup the numbers together. So we have 5 x's and we're adding 4 x's. Since they have the same variable part, we're allowed to regroup and say how many parts we have, how many x's do we have. And this is simplification of an expression because we don't have an equal. It's not an equation yet. It's just on, let's say, the left side. We're only dealing with the expression on the left right now. 5x plus 4x simplifies to a 9x. So we keep the same variable part, but we're regrouping on how many of these items or variables do we have. Taking that combined like terms and extending it into things that are not like. If we had a problem like 5x plus 4y, would we be able actually to regroup those things by addition? And if we look at the variable part, we have an x in the first term and a y in the second term. They're unlike terms because the variable part is not the same. So can we actually add 4 y's to a 5x? And we can't. We can't combine these because they're not like terms. So that's a quick refresher of the like terms and the process we went through. So now that variable part is going to turn into a radical part. So let's start with, let's say, 9 radical 10s, and we're going to add 2 radical 10s. Do you see how this is kind of like a 9x plus a 2x? You got to extend that idea of the variables into radical parts now. So if we had 9x and we're adding 2x, we check to make sure the variable parts are the same, and then we recombine and tell you how many of those variable parts we have. And we have 11x variable parts. So extending that knowledge into our radicals. If we have 9 radical 10s, and we're adding it to 2 radical 10s, checking that part, but now it's not a variable part, it's a radical part. So we have to check to make sure the radical part is the same. We have a radical 10, radical 10, same radical part. I'm allowed to regroup and add those terms together. So 9 radical 10s plus 2 more radical 10s gives me 11 radical 10s. So now you can see that idea of combining like terms extend into our radicals as well. So that's how we're going to start combining like terms. However, what if the radical parts are not like? So if we had something like 5 radical 3s, and we want to add that to 2 radical 2 radical 5s, can we do that? So we first have to ask ourselves, are these terms like? If they're like, we can combine them. If they're not like, we're done. They're simplified as far as we can go. So we have a radical 3 part and we have a radical 5 part. Can I combine radical 3's with radical 5's? And the answer is no. Just like you wouldn't be able to if this was 5x plus 2y. We can't combine those things because their parts are not like. So again, we need to first check to make sure the radical part are like, and if they are, then we can regroup by addition or subtraction. And we're going to move into that section now. Alright, so we're going to start adding and subtracting square roots in section A. So looking at our first one, simplify 5 radical 2 plus 4 radical 2. Now remembering correctly, we have to check to make sure these terms can be combined by checking the radical part. So if I look here, I have a radical 2 part and a radical 2 part. Therefore, these radical terms are like radical terms, and we can combine them by addition. So we have 5 radical 2's, and we're adding it to 4 more radical 2's, giving us how many radical 2's? So 5 and 4 make 9 radical 2's. One important thing to focus on, when we combine the like terms, the part does not change. So taking that back, 5x plus 4x gives us 9x. Do you see how the variable part never changed? Just how many of those variable parts we had changed. You need to just take that into consideration. So 5 radical 2's plus 4 radical 2's leaves me 9 radical 2's. So please make sure that you're not changing the radical part. The second one we're going to do is just like addition, we should be able to subtract these as well. So our second one is subtraction. So we have 2 radical 3's, and we're taking away 7 radical 3's. First thing to do, check to make sure they're like. To check if they're like, we look at the radical part. So the radical of 3 is the first part of term 1, and we have a radical 3 is the second term. So since the radical parts are the same, these two terms are considered like. And because they're like, we're allowed to add them and subtract them. So we have 2 radical 3's, and we're taking 7 radical 3's away. So we have 2, we're taking 7, so we're left with negative 5. What? We're left with negative 5 radical 3's. Remember, the radical part does not change when we're adding or subtracting. We're just regrouping on how many of these radical parts do we have. So 2 radical 3 minus 7 radical 3 leaves me negative 5 radical 3's. So there are 3 problems on the bottom that you are going to do right now as your checkpoint. And we'll check those over tomorrow in class.
Make sure you copy down your checkpoint, complete the 3 checkpoint problems at the bottom, and we'll discuss the solutions tomorrow. Please make sure you pause the video to be able to write those down. This is the end of Day 1, Part 1, so please make sure you go back and click on the next video named Day 1, Part 2. Both of these will be discussed in tomorrow's class.